Accommodating quality of service, QoS, features. QoS will allow you and your telephone carrier to prioritize traffic according to the type of application using your bandwidth and adjust between your different telephone needs at a moment's notice. Only now are we beginning to see the potential of 4G applications. They are expected to include high-performance streaming of multimedia content. The deployment of 4G networks will also improve video conferencing functionality. It is also anticipated that 4G networks will deliver wider bandwidth to vehicles and devices moving at high speeds within the network area. Session 2. Title: Information Transmission Process. Topic 1. Generation of audio sound. What is sound? A sound is a longitudinal mechanical wave which is caused by the back and forth vibration of the particles of the medium through which the sound wave is moving. The vibration of the object set particles in surrounding medium in vibrational motion, causing the auditory receptors to detect them. When the vibrations are fast, one will hear high note, whilst low note is heard. When vibration is low, the human ear can detect frequencies between 20 Hz and 20 kHz. Sound travels at 340.29 meters per second at sea level. A sound, in air, is made when air molecules vibrate and move away from the vibrating source in a pattern called waves, or sound waves. Sound is a mechanical, longitudinal wave that moves in all directions and travels in waves of compressions and rarefactions, expansion, as it successively passes through a medium. Air particles moves into and fro position where they collide with each other to form a cluster, compression, then they rebound from each other, the same effect of hitting a ball against a wall, rarefaction, i.e. a series of mechanical compressions and rarefactions. Sounds are carried this way by the air particle in an outward fashion, similar to ripple in a pond, as it continues to collide with air particles. The air particles do not move over a large area, but carry the sound by colliding with other air particles. This way it passes on the vibration similar to a domino effect as it moves away from the vibrating source. Vibrations of frequencies in the approximate range of 15 to 20,000 Hz can be detected by human ears. Types of sound. A audible sound is a sound which human ear can detect. An inaudible sound is a sound human ear cannot detect. An infrasonic sound is a sound below 20 Hz frequency. Ultrasonic sound is a sound above 20 kHz frequency. Component of sound wave. A wavelength is the physical distance between two consecutive crest or trough in a sound wave. To NB, crest is the high pressure and trough is the low pressure area in a sound wave. Amplitude is the magnitude of compression or expansion experienced by the medium the sound wave is traveling through in distance between the midline of a wave and its crest or trough. Pitch/frequency. A wave's frequency is the number of cycles that are completed in a certain amount of time. A number of waves something produces in 1 second. It is calculated in cycles per second. The SI unit of pitch/frequency is hertz. The frequency of a wave refers to how often the particles of the medium vibrate when a wave passes through the medium. Measure in hertz period as the amount of time it takes for one cycle to complete. Period, being a time, is measured in units of time such as seconds, hours, days, or years. Frequency refers to how often something happens. Period refers to the time it takes something to happen. Frequency is a rate quantity. Period is a time quantity. Frequency is the cycles/second. Period is the seconds/cycle. Period equals 1/frequency. Frequency equals 1/period. The period of the sound wave produced by a 440 Hz tuning fork is understood given. F equals 440 Hz fine TT equals 1/F equals 1/440 Hz equals 0.00227 S. Medium of transmission. A medium is a material through which the energy wave can propagate, including a gas, solid, liquid. Gas is a medium. A dot in gas, particles in gases are very far apart from each other. They can vibrate as well as move freely and randomly in all directions. This is due to the fact that the force of attraction between the particles are negligible. This means, therefore, that there is no force of attraction between gas particles. Gas molecules must move quite a distance before they collide with other molecules. Sound energy cannot move as quickly when the molecules are not in contact with each other. Thus, since gas particles are very far apart, sound waves traveling through this medium will be much slower than that of a liquid and a solid, respectively. Because of gas particles being everywhere on Earth, we can hear sound from all directions. Solid as a medium. A solid is made up of particles, atoms, that do not move about because they are closely packed, touching each other, and held together by strong intermolecular forces. Therefore, they are always in a fixed position and can only vibrate in a fixed position, sending sound waves along its path very fast. This is similar to a domino effect. This means that sound waves, produced from a vibrating source, is immediately transmitted by the vibrating particle in a fixed position by hitting the neighboring atom, sending on the sound wave from one atom to the other throughout the solid object. Liquid as a medium. In liquid, the particles are constantly moving, and so the particles change their position, but they are not fixed to each other that strongly as they are in a solid. They can also vibrate and collide with other of their particles over a short range, sending sound waves through it. This is because the attractive forces among the particles of a liquid are sufficiently strong enough to hold them together, but are not strong enough to hold them in a fixed position. As such, sound will travel slightly less fast through liquids. What is modulation? A modulation is a process by which a carrier wave is altered in such a way that it's able to carry information on it. It is the process of superimposing a low-frequency signal on a high-frequency carrier signal.